Hello, good morning to all. Kamtekar here, as you know me, and today I am taking your analytical paper number first. In that, four units are there. First one is quality in analytical chemistry. First, second one is quality in analytical chemistry. Second, third one is chromatographic technique. First, that we are going to study now, and fourth one is chromatographic technique. Second, in chromatographic technique, what do you know the what is mean by chromatography? Chroma means color and graphy means study. Here you can see chroma means color and graphy means study. You know the paper chromatography, there is a separation of spot and different colors are obtained on that paper. From that we can identify the element or compound in the respected solution. Here first, in this 3.1, this one is unit 3, and from that first point is 3.1, that is ion exchange chromatography. You know that ion exchange chromatography you are studied in TY. They involve this chromatography involve reversible exchange of ions. The some chromatographic method. Among these various chromatographic method, most frequently used method is ion exchange chromatography as well as gas chromatography. The wide application in the organic chemistry, while the latter is very useful in separation of organic compounds. Separation like separation of chemically similar element like zirconium and hafnium, rare earth, or niobium tantalum also. What that was possible by this technique, ion exchange chromatographic technique. This is also this softening or deionization of water was facilitated by the ion exchange process. Also the removal of total salt concentration and the removal of interfering ions, separation of ions from non-electrolytes or isolation of trace concentration of precious metals. Next, uh, this the separation of non-electrolytes, trace concentration of precious metal. We can see the for this separation we can study the various technique. That also we see next. The advantage of this ion exchange method is this procedure is very simple, rapid and inexpensive. The resin can also be reutilized after regeneration, and they are easily available in any particle size with varying exchange sites. Also they are insoluble in water also. What I said, they are labile, that is they can be detached and hence they exchange radially. This is the introduction of ion exchange chromatography. Next one is ion exchange chromatography. In that, two types of exchanger, liquid anion exchanger and liquid cation exchanger. You know the cation exchanger and anion exchanger. In anion exchanger, quaternary ammonium chloride are strong anion exchanger, whereas the tertiary or secondary amine salt are weak anion exchanger. You saw this in TY. Here you can see liquid anion exchanger. Anion exchanger, it is negatively charged, and this having high molecular weight amine depend on their type of amines like primary, secondary, tertiary and quaternary amine. And this liquid anion exchanger having 18 to 27 carbon atom. Also they having aliphatic amines. Aliphatic amines, like example amberlite La1 and La2. Liquid anion exchanger form salt as here example. Liquid anion exchanger. This is the general you saw in TY. Exchange of anion X minus and OH minus. Here the exchange of ions. Here here X minus is released ion. Now you, in part 1, this one is the example for your study. This one is used. Exchange of X minus ion. Can you see this? Second example is this, and here you can see the exchange of X minus ion. This is attached to NH3. Here you can see an X minus is released. That is labile. These exchangers are acid soluble in water, and the total number of carbon atom are 10 to 28. Next one is they all involve transfer of species of ions. They having small solubility in water, and that saw in just we saw it in introduction. What? This solubility, small solubility in water. Next, having large specific exchange capacity. Also large solubility in organic solvent, high selectivity and solubility. They have fast exchange rate and having no problem with suspended matter. Do you know the diagram of resin column? Here you can see the diagram of resin column. This one is the respected solution, cationic or anionic solution, and here is the resin that was soaked in overnight. If you know, do you remember the properties of ion exchange resin? It should insoluble in water. Also they denser than water, polymeric structure should be loose and porous. Also, they provide large number of ionic site per unit mass of the material. That these all properties you are studied in TY. Next one is liquid cation exchanger. You saw that you saw the cation exchanger in TY. In that, the replaceable ion is positively charged. In that generally exchangeable cation is labile hydrogen ion that are exchanged with the cations in the solution. The sulfonic acid SO3H group or carboxylic acid, that is COH group. Thus the sulfonic acid group is permanently ionized, whereas the ionization of carboxylic acid group is depend upon the pH of the solution. It increase with increasing the pH of solution. This the resin having the SO3H group as a functional group. Sorry, is there any disturbance behind this video? Please kindly avoid it. Please. Those with carboxylic acid COH group as the functional group are called the weak cation exchanger. SO3H is strong cation exchanger and the COH minus COOH is weak cation exchanger. Here you can see the general reaction that you have studied in TY. Here is the exchangeable ions, and in MSc you can study this example. It is this liquid cation exchanger similar to solid cation exchange resin as H2R. They all have replaceable group as H+. And resin represent in liquid form, also called liquid cation exchanger. What I said, the resin present in liquid form called liquid cation exchanger. They act like cation exchanger during the separation of ions. Here is the example. H plus DHPO plus CaCl gives replace H is replaced by Ca-. O means it is in organic phase. So here you can write O. This represents the exchange of Ca on cation exchange resin. Inert diluent for this reaction we can use inert diluent like xylene, toluene or benzene for this separation. Next one, this solid cation exchanger can be converted back to H plus form, as here you can see the reaction converted back to H plus form. What I said, solid cation exchanger can be converted back to H plus form. Ca here HCa and H plus is replaceable. H is replaced by C. Here you can see. Also the method can be recovered from organic phase. Here you can see the metal can be recovered from organic phase with sodium carbonate. As here is the example. Okay, what we see now, unit 3 chromatographic technique. First, in that 3.1 ion exchange chromatography, two types, liquid anion exchanger and liquid cation exchanger. Thank you.